In this lesson, we're going to look at how to interact with GUI components in general. It turns out that GUI systems, including Swing, must run in a single-threaded way. Since Java is multi-threaded, this won't actually happen by default. But there's an easy utility to allow us to do our interactions correctly. Additionally, if we want our UI to remain responsive, we must avoid performing long-winded processing in our event handlers. There's another utility to help us with that. Let's take a look at this example in the project Swing Updates. We have the same kind of configuration we've seen a number of times before. We create an instance of the enclosing class and call a method on it called Go. Here's the Go method, so this is where the work happens. We create a JFrame, we set a layout, which is going to be a grid layout with 2 rows and 1 column. And then we create a button and a text area. This time we're creating a scroll pane for the text area. So this scroll pane will allow us to scroll the text area around if there's more text in it that can be shown in the window. We add a listener to the button. So when the button gets clicked, we should print out the message, "Button was clicked." Then we add the button to the JFrame and the scroller to the JFrame, set the close operation so it will actually shut the system down, set the size and boundary of the JFrame and make it visible. So if we run this, we can see that when we click on the button, it prints the message, "Button was clicked," down here. Although it's not obvious, this program has 2 threads running concurrently. There's the normal thread, that's the one that runs our main method, but there's another thread that is created to handle the user interface. That other thread handles our mouse and keyboard interactions, like the click, along with some other related UI behaviors. We can demonstrate this by asking the threads to tell us their names. We'll add some code to the main thread just after it has created and launched the user interface. So we'll put this just here. This one says print out main thread name is, and then this code here goes and says whatever thread is running me, get a hold of the object that describes it, and then get its name as text and print it out. The other thing we'll want to do is each time the mouse button is clicked, we'll add some code here. So this is going to be essentially the same kind of code, but this time it prints out user interface thread name is and prints out the name of the thread. Let's save that and run it. Here you can see main thread name is main. When we click on the button, however, it says button was clicked, UI thread name is AWT event queue0. Let's close this one down. So you can see from the different thread names that we really do have 2 different threads working. Well, why should we care? Well, suppose we wanted the main thread to write text into the text area at intervals. We would probably try something like this. Let's put some code just in here. This goes into an infinite loop and it uses this method thread sleep. And what that will do is to suspend the thread for, in this case, 2000 milliseconds or 2 seconds, and then continue by calling the append method on the text area along with the date stamp. The try-catch around this is because the thread sleep method actually is declared that it might throw an exception, and we're obliged to handle it. So if we save this and run it, we can see that at 2-second intervals, the main thread is updating our user interface component here and is writing messages into that. So what's the problem? That seems easy enough. Well, the problem is that it's not safe to interact with GUI components from any thread other than the event thread. That's the one that handles the button click. The odd thing is that this works almost all of the time, so you could easily fall into the trap of doing it this way. What we actually need to do is to ask the event thread to do the work of interacting with the GUI components for us. We do this by wrapping the work up in a special package called a runnable. Runnable is an interface, and we almost always use an anonymous inner class to do this. In a runnable, the run method is the place where we put the work that we need to do interacting with the graphical user interface components. So what we need to do is to embed this line, the text.append, inside the run method of a runnable. Let's go ahead and create a new runnable and we'll create the basics of an anonymous inner class. And if we click on here, we can implement all the abstract methods. So there it's created an unimplemented body for our method. We want to move the append method call inside there. Now that we've got this runnable, that defines our work or our job description if you like, we can pass that to the event thread using the Swing Utilities class. This class provides a method called InvokeLater. So we will say Swing Utilities dot InvokeLater, and then we provide our runnable as the argument to that. And we need an import for it. So now what we're doing is we're telling this utilities class that at its convenience, and it won't wait too long, we want it to use the event thread to run this code, the code defined by the run method in this runnable. So if we save that and run it, we notice that we still get our updates and they're still at 2-second intervals. We can still click on the button. So it looks like nothing has changed. But the important thing is now this code is safe. The problem really is you rather have to take it on trust that this is the right way to interact with GUI components and that what we did before was wrong. The wrong way won't fail every time. In fact, it won't fail at all unless the event thread and the other thread happen to interact with the GUI at the same time. Even then, there's a fair chance you'll get lucky and it'll just work. So remember, you must interact with GUI components using this approach unless you're already using the event thread. So how would you know you're using the event thread? Well, generally, if you're in an event handler, one of the callback handlers that you added to a component, like this button handler that we have here, then you're in the event thread. Also, if you've been invoked using the Swing Utilities InvokeLater method, then you're in the event thread. If you're unsure, you can always print out the name just to check. There's another rule regarding these threads. We mustn't do long-winded processing, for example database searches, using the event thread. The problem is that if you do, you will prevent the user interface from doing anything else until you're finished. This could happen if we were to include this sleep statement here in this run method. But a more realistic situation is to have an extensive computation in an event handler. So our event handler for the button is up here in this actionPerformed method. So let's add a lot of computation to that. What we'll do just after we've printed out the name of the thread, we'll add a loop. We're going to say starting so we can see that it's doing something. And then we're going to create a very large number, 50 million date objects. I'm going to abandon them. They're not going to do anything useful, but it'll take the system a little time to achieve that. So if we save this and run it, notice what happens when we click the button. So at the moment, everything's working. We're getting this output. We can click that, but then I can't do anything. It says starting, and for as long as it hasn't finished, the system basically hangs up. Then when it finishes, see it said done now, then things come back to life. But each time I click on this, I can't resize the window, I can't type characters in this field, and everything basically hangs up. So let's close this down. And then the question is, what am I going to do to actually make this work properly? Well, what we have to do is to pass this work off to another thread. This is similar to passing the update behavior to the AWT thread, the event thread. But we're doing this the other way around now. We're in the AWT thread and we need to find some other thread that we can use to handle the work. Fortunately, there's an easy way to do this. There's another utility called the Swing Worker. This one actually uses a slightly different packaging mechanism from the runnable we used last time. Let's bring a piece of code in that does this in its simplest form. So here is our long-winded code. I'm going to embed that inside this Swing Worker. So here we construct this anonymous inner class. It's a subclass of the Swing Worker class. What we've done is simply put our behavior in this doInBackground method. That's kind of the same as putting the behavior in the run method previously. Now the doInBackground method is actually declared as returning an object, but we're not using that aspect of it, so we can simply return null. So what's going to happen when we come into our actionPerformed method, we'll print this message and this message in the event thread, but then we will set this new job up so that another thread created for us by the Swing infrastructure will execute all this code. I'm actually going to reduce the time that this blocks for, because otherwise it gets a little boring, and then we'll click on this guy and run it. So let's bring this down here so we can see what's happening. We're still getting our updates. When we click there, we see starting, and then a second or so later we see done. If I click this several times, we see lots of startings, but I can still move this, and then we see a lot of dones. So the nice thing is that all that work is being done in another thread. It's actually not the main thread, neither is it the event thread. The important thing is that it's not the event thread. Here's one last thought. What do you suppose would happen if you wanted to update the graphical user interface when this work done in here was completed? Yeah, that's right. This is not the event thread, so you can't do it directly here. You'd have to use the Swing utility invoke later behavior that we looked at earlier. This can all seem a bit messy until you get used to it, but you do get used to it, and then it's not so weird. By the way, this behavior is not unique to Swing. Pretty much every GUI tool around works this way. It's just kind of a law of physics that you can't have concurrent access to a graphical user interface and expect things to work well. So this lesson has looked at the threads that are alive when a GUI program is running, and investigated the rules that constrain our interactions with GUI components, and the key utility classes that we can use to make usable GUIs while adhering to those rules.